Here is an update video. So I've got this little thing here in front of me. What it is a 2-inch diameter steel ball. Oops, I tapped it. That's inside here. You see it? I guess I can move it around. Anyway, then it's got two identical coils on either side of it. I know they look different. This one is wrapped with a sort of paper core. I think it's number 19 gauge, but I can't remember. They're identical length of wire. I had 12 of them at one point for another project and ended up using them for various things. But these are wrapped on the same PVC pipe form. This one's covered with electrical tape. This one is with clear tape and paper. Anyway, hopefully I can make it stop spinning. Anyway, it's dangling from the roof. It's hooked to an audio amplifier here that normally leads back to the signal generator. So right now, it's running at 300 cycles a second, and both the phases are the same. So if I go and change the phase, it doesn't do anything interesting. Basically, all it does is take the node points inside that steel sphere, and I think these are set up for attraction. Pretty sure that's the way I did it. I got all the wires hooked up right. Anyway, so if I adjust the phase of the two, it just changes where the node points are in the standing wave. So, okay, fine. It doesn't really do much. It doesn't do anything. Now, if I accidentally overload the amplifier, this thing moves quite a bit, which is kind of fascinating. It jumps. So that's the first clue something's going on. So I tried a different format, and anyway, here's my signal generator screen here. So 90 degrees. Oh wait, I'm sorry, I'm messing with it. Channel 2 is 90 degrees. Channel 1 is 0 degrees, and that gets us this. So, anyway, not useful. So if we go load another preset, this is what happens when you put a slightly different frequency. You can see the frequency between the two is 1 cycle per second out of 300. And you get the node points moving in the standing wave. And I know a standing wave is not supposed to move, but I don't have better words for it, so a motional standing wave. And that does some very interesting stuff when you put it into here. It appears to move, but it like grabs a hold of everything around it, like, I don't know, the table, the wire, the whatever it is. It just moves, which is interesting. Maybe it's pushing ions around. I really don't know. So I did the same thing with my iron cube wound in 3 different directions, and I hooked up 2 of them with that. In the third direction, I would set a stack of magnets on, and I could either put them where this is up and then the magnetic field is rotating around because of what it's doing there, or I could set it on the other side. Anyway, the phase angle of 90 degrees works really well with this thing because it makes a rotating magnetic field. And if I have this on the side or the top, it does slightly different things. I'm not sure that's useful to talk about because there's something way more entertaining, which is if I set the signal generator for a square wave, and I've got the the duty cycle set for 50% on both of them. And then I've got the little knob here where, I can set the duty cycle for either 60 or 40. So the goal is 60 or 40. I can't record and do this at the same time. Anyway, so 60 or 40, and you see the little graph there on the signal generator change. What's interesting is you get the same thing on the oscilloscope. So there's them matched, and it's one side and then the other. I found out a bunch of people have thought about this before. Oh, by the way, the moving standing wave thing, thank you, Ciro. You're the one that showed me that that is useful. And then this one with the duty cycle changing, Jeremiah Pop told me about this one, which is interesting because what it means is these two coils turn on at the same time, and then they turn off separately. So given the speed of light change or distance between the two coils, they will attract equally to the core in the middle, and then the one turns off first. So the other one feels that change until it gets to the other side, and there is a delay time there. And I'm surprised at 300 cycles a second I can see anything, and I can. So I'm going to turn off the oscilloscope, and I'm going to unplug my two connections and hook up the audio amplifier. And I'm sorry, normally I'm a lot more set up than this. It's just something that if I try to save 30 seconds of filming, I'm really going to fail, because it's just kind of too obnoxious to do. Anyway, I've got the power supply set, 13 volts. I've got the amplifier over here. It's a Class AB amplifier, and it's turned all the way up. So 13 volts is not its limit. I think that's 18 volts. So I'm going to hold the camera up against the edge of the table here so that you can really see this moving or not. Now I'm going to turn the power on to the amplifier. This little switch turns on. I don't know if you can hear it on the microphone. There's now a 300 cycle per second tone. Now I'm going to turn the duty cycle 60% and then to 40. Back and forth between 60 and 40. And you can see it start to move. So it's making a very tiny amount of thrust, which is absolutely fascinating. So it's just 60 versus 40. Oops. And that's all I was doing to get it to move back and forth. And I know it's a very tiny amount, but the whole trick to this, turn the amplifier off so it doesn't melt, is that tiny forces like that aren't generally horribly useful. But let's say we take something like the bagel coil here. Now this is a 24 turns, and 24 turns makes this one up. So Bob Grenier pointed out that you only need 3. So I'm like, okay, fine. I only need 3. I'll take 3 coils and I'll set them in a circle. So now I've got three coils in a circle. Great. I'm going to use 3 of these and set those in an equivalent circle and try to make a skeleton bagel coil field. And something I thought about is, how do you trap smaller bagel coil fields, like the exotic vacuum objects or electron charge clusters or whatever you want to call them? And let's say something like a Jacob's ladder, because that's a fun toy to play with. It'll make a lot of these things in the air. So let's say I go ahead and set that up, or something equivalent, just a spark gap, inside of a bagel coil field. So let's say I do it, I don't know, the size of a room or so. It should have a high enough magnetic field to cut off the interaction of gravity from the outside world, which, okay, great, but then how do you move it around? I think this little toy with the 2 coils on either side of the little sphere, and I haven't tried other cores. Well, I guess I tried one other core. I tried or 2 other cores actually. I tried an iron cube. This is a pure iron cube, and it didn't work, which I thought was interesting. And then I tried taking and doing a similar thing with this one here, which is a resin container with 2 coils on it that I filled up with the black iron oxide. I have got a whole pile, wherever I left it, of black iron oxide. Oh, I think I lost it. Anyway, I basically just filled up little plastic bags inside the resin container, and it was extremely heavy. So maybe that's why it didn't move. I don't really know. Maybe it just got lost in all the little particles, but I'm going to try more experiments to see. But if you've got something that doesn't react to gravity in the first place, a tiny amount of force should be pretty useful. Anyway, that's my plan for doing, I don't know, something interesting, I guess is the way I'd put it. Anyway, so that's the update video and what I've been thinking. And I guess that's about it. Yeah, the phase shift angle, not very useful unless you're in a spinning field, in which case it does the very, almost exactly the same thing as the two different frequencies slightly off the moving standing wave that this thing will do. But what I find very interesting is that it looks like the Star Trek stuff of the tractor beam. This thing grabs a hold of everything around it. That's useful. And then the moving without caring what's around it, as to the square wave put into it, it simply creates motion and it doesn't care about what's around it. Both of those appear to be equally useful, just very different. Anyway, thank you, Ciro and Jeremiah Pop, because those were fantastic ideas. So, okay, bye.